Alright, so you subtracted 9 on both sides. X is greater than or equal to 4, and you graph it. Number 2, what am I doing here? Byron.
You're going to want to divide -4 both sides. Since you're dividing by negative, you're going to have to split the sign.
Okay. So -4 divided by -4 is 1, so I've got x. Because I'm dividing by a negative number, I flip the sign. 12 divided by -12 divided by -4 is 3. So to graph that, I'm going to go 2, 3, 4, 5 here. Open or close circle? Open. Because x cannot equal 3. Feeling good? Okay. So, what we're going to do today is basically, we're just adding a couple steps. So, instead of the one-step inequalities that we've been solving, we're going to go multi-step. Mr. West. Do these the exact same way as you would do a two-step equation. If you add or subtract on both sides, what happens to the inequality? Stays the same. Adding or subtracting, the sign stays the same. Multiply, divide by a negative number. If you ever do that, multiply or divide by a negative number, you flip. Multiply or divide by a positive number, stays the same.
So it's only to divide.
Yes, you guys are both on the right track. The only time the sign flips is when you multiply or divide both sides by a negative number. Sophia.
I was kind of off topic, but the pi day.
So here's how we're going to attack this guy. Well, I mean, what do you think the first step is?
You would add 6. Where do you get the 10?
Divide every single one by 2.
I'm going to add 6. I'm going to add 6. Zach Barnes, I know exactly what you're going to say. I'm going to get to you in just a second. You can totally do that. So, add 6 on both sides. That's 2x is greater than 2. Divide by 2 on both sides. You get x is greater than 2. Then you got a graph.
Does the variable have to be on the left side?
Variable, does it have to be on the left side?
I hate graphing. You should make my life so much harder.
Does it have to be on the left side? No, it doesn't.
Okay.
So I'd like you guys to... Alright, here we go. So, letter B was basically the exact same thing as letter A, just different numbers. So I want to touch on what Zach wanted to do with letter A. Zach, what did you want to do with letter A that we can also do to letter B?
Done.
Yeah, so he saw that 2 goes into each of these evenly. You don't have to do it that way, but I'm just going to show you it because it's certainly another way to solve the equation. So if I divide each of these terms by 2, I get 2x minus 5 is less than or equal to negative 3, and then I can solve for x. Adding 5 to both sides, so I get 2x is less than or equal to 2, and then I get divide by 2, x is less than or equal to 2. Open or close circle at 1? Closed. Which way should my arrow point? It should left.
Diagonal to the right.
Okay. So now somebody walk me through letter C. Rachel.
I guess, well, you would combine the x's so you would add 2 to both sides.
Add 2x to both sides?
Yeah.
No.
I don't know. Go ahead, take it.
No, I'm good with adding 2x to both sides. I'm good with adding 2x to both sides. So we are combining like terms here.
Yeah. And then I got negative 3x plus 3. Sine 18.
Guys, you listening?
Less than or equal to
Alright.
And then you would subtract 3.
Mm-hmm.
Negative 3x plus 15.
or exactly 52.
Divide by negative 53, flip to both sides, and you would get x is less than negative 5.
Okay, so we divided by a negative number. So what happens when we divide by negative?
I did flip it. I did. I just forgot to say it. I flipped it.
So we should get x is greater than negative 5. So when we graph this,
Hey, I did a different method, I'm sorry. Yeah, but yours is more long.
let us open or close circle at 5? Negative 5?
Open.
Open. Oh, thanks. First row. So let us. So somebody walk me through D here. I mean, I can shake her up. Sky.
Yeah, shake.
Track 5. And what's that get me? Three. Okay. Multiply both sides by 3. So I've got, which way should my, well, I've got, do I have an open or closed circle at 6? Closed. Which way should my arrow point? Left or right? Left or right?
The left side. Take two left.
Left side. 6 is greater than x, so x has to be less than or equal to 6. This is the same thing as x is less than or equal to 6. Okay? I'm just going to breeze through E here. I'm going to subtract x on both sides. That gives me 2x plus 2 is less than 4. So I'm going to subtract 2 on both sides. So that gives me 2x is less than 2. Divide by 2 on both sides. So x is less than 1. Graph it. Open or close circle at 1? Open. Left or right arrow?
Nice, those first time.
Sweet. Now I'd like someone to walk me through their thought process for F. Nathaniel. Okay, we're going to use the distributive property, so what do we get on the left side? Plus 21. Perfect. Okay. Adding 7x to both sides. You're skipping some steps on me. So so on my left side I've got 21 left, and that's greater than 26 plus 5x. Mhm. Okay. So I'm going to say negative 5 is greater than 5x, and then I'm going to divide by 5. So I get negative 1 is greater than x, which is the same thing as x is less than negative 1. And then you can graph it on your own. Questions about these multi-steppers? Okay, flip it over.
Oh my god.
Flip it over.
Easier.
So, now my question for you is, if you remember back from your solving equations days, what happened when I don't know why I'm phrasing my question this way. When did your equations have no solutions?
And they both
When they had no solutions.
It's like
When the
What do you think is going to happen to this inequality if we have no solutions?
They have 5x on both sides.
Okay. But what do you think our end result is going to be? Are we going to get a true statement or an untrue statement? Untrue statement. So, let's solve this thing out. So let's do the distributive property. So we have 5x minus 10 on the left side, and that's less than 5x minus 12 on the right side. Let's subtract 5x from both sides. So that gives me negative 10 is less than negative 12. Is negative 10 less than negative 12?
No.
It's not. So since this is not true, we say this has no solutions. Yes, sir. Uh-huh. So now, do the same thing over here. So we'll use the Zach Barnes strategy and subtract 5 on both sides first. Yep. So I've got negative 3x plus 3 is greater than or equal to negative 3x. Now we'll add 3x to both sides. You could do that, but this is even quicker. So then I get 3 on that side is greater than or equal to 0. Is 3 greater than or equal to 0?
No.
Yes.
3 is certainly greater than or equal to 0. So since this is a true statement, we have all real numbers, our solution. So for letters A, B, and C, I want you to solve these things to identify the number of solutions in each. So my strategy for these is to get rid of the x's first. So for A, I'm going to subtract 2x on both sides. This gives me negative 7 is greater than negative 9. Is this true?
Yes.
Is negative 7 greater than negative 9?
All real numbers.
Yeah. So all real numbers are solutions. If you got a different number, if you got something like 2 is greater than 0, yeah. So is that a true statement? So then you got the same answer. Okay? So now B. Well, let's do the distributive property. Got negative 3x minus 9 is less than or equal to negative 4x minus 5. Can you tell already that this is not going to fall into either of these categories?
Oh, is it 1? It's a 3.
Well, we can't say that there's just one solution because
Every number.
I'll tell you why in a second. So what should my step be here? What's my first step?
You could either add 4x or add 9.
I'll add 4x. So I get x minus 9 is less than or equal to negative 5. Now what do?
You could add 9.
Add 9 to both sides. So I get x is less than or equal to 4. So, Alex, in this case, we get x is less than or equal to 4. So it's not just one solution, because all of the numbers that are less than or equal to 4 are solutions.
So you can say all numbers close to negative 4?
Yeah.
So that's
I get it.
So is that just A right there?
Yeah, that's our solution. So we can come up with a clear solution for this one. So what about C? Somebody I haven't heard from today. Tell me what my first step should be. Somebody I haven't heard from. Nate.
Yes.
That's a great suggestion. So what do I get? Well, okay, so after I subtract 4x, what is my inequality reduced to?
5 is greater than or equal to.
And is that true? No. So we get no solutions. Okay? Alright, now I threw in a little word problem for your enjoyment here. So you're saving money for a summer camp that costs $1,800. So far you've saved $500. Good job. You've saved $500. And you have 14 more weeks to save the total amount. So what are the possible average amounts of money that you can save per week in order to have a total of at least $1,800 saved? If I need to set up an inequality here. How should I start to set this up? Wes?
You do 1,800 and put that, and then
Okay.
what you do is you would do a greater than or equal to sign,
And why would I choose greater than or equal to?
because you can either go above the amount or equal to the amount, because summer camp, it costs a certain amount of money, and if you go under that, you can.
So I want 1,800 is greater than or equal to? Is that what you're saying?
Yes.
So 1,800 is the biggest amount that I can save? Is that what you're saying?
That's small.
That's the smallest amount.
Yeah.
So maybe rethink your inequality.
No, sorry, I'm thinking of it the other way. If you do 1,800, then you put a less than equal.
Good. Less than or equal to, because 1,800 is the lowest amount that we can save in order to attend this summer camp.
Yeah, I did it the other way, so 1,800.
Gotcha. Then that would be correct. Zach, you want to carry us through? Okay. Yeah, that would be a good step. So that's going to be like the first step to solving the inequality that we're going to come up with. So now on the right side, we need an expression for the total amount of money that we're going to save.
14x plus 500.
Okay, so 14. So 14x. Why did you say 14x?
You have 14 weeks, and you need x to do the total amount of the average.
Yeah. So let's define x as the average money saved per week. And then Kramer, why did you add 500?
Because you already have 500.
Because you've already saved with 500.
Good job, Carol.
Thanks, Bart.
Good. So now Zach said our first step is to subtract 500 from both sides. So this gives us 1,300 is less than or equal to 14x. So what is this saying in terms of our problem?
You have 14 weeks to save up $1,300.
You have 14 weeks to save up $1,300. So Wes, take us home now.
You divide by 14x and 14.
Okay. And then does someone have a calculator?
92.87.
92.85.
I'm going to go with 8.6.
857.
I'm going to go with 8.6 is less than or equal to x. So in the context of the problem, let's bring this all together. Someone I haven't heard from, what is our inequality saying here? Someone I haven't heard from.
Oh, yeah.
Sophia.
Say if you had to save on average $92 a week, then you should get back to get $1,800
Good.
or more.
Or more. I'm glad you added that in. Thank you. So this is saying we need to save at least $92.86 per week to attend our summer camp. Well, you're also not a working person.